All right, I'm in. Let's do this. Okay. So yeah. Now that I'm streaming on YouTube. Sorry that took a minute or two to set up. Back at home, Goose is here with me. I've got all the support that I need. Yeah. So I didn't go to school today. I just didn't want to have to deal with the computer there today. And I learned a little bit more about what to expect for next week. Things are constantly changing. We're learning new information. We're getting new directives from the government, and things are opening up, and they're opening up in ways that we can't necessarily predict. You may have heard that school is going to be opening up. And you would have heard correctly. So Monday, schools are reopening, but don't think that you're coming to class because you're not going to school on Monday. I can promise you that. As far as I understand, pretty much nobody is, no students are going to be coming to school, certainly not on Monday, and probably not for the first week. So not for the first week of June, while we still kind of figure out our physical distancing protocols. If you've been to a grocery store, you're familiar with the whole, the rigmarole, okay, spray your hands and this kind of thing. I don't think we'll be going full out in that respect. I don't know if anyone's going to be at the front door spraying your hands. But the whole idea is that it will be by invitation only. So this is if maybe you're struggling and maybe you're at risk of not receiving your credit, then you may be asked to come on down and have a meeting with your teacher to see what we can do to try to get the ball rolling, just to see if we can squeeze out one more assignment out of you so that you can pass and that kind of thing. Maybe provide some one-on-one support, obviously while remaining, having some distance between you, obviously. So that's kind of where we're at. Now, what that means for our class is... teachers have been asked to come into school, the building, for 50% of the time for the next few weeks. I just asked my principal, Mr. Hutchison, if it was okay if I kind of did the following sort of schedule. So what I'm going to do is, as of next week, our classes, our online classes, as they are now, they're going to be cut in half. So I'm going to be streaming every second day. And on the other days, I will be at school, and there's a whole lot of other sort of administrative tasks that I need to do, and I need to do them at school. One of those tasks that I have to do is to provide a document for you. And that in that document, I'm going to outline the big picture ideas of what this class is. So this actually may help you quite a bit for your topic map, because I'll be listing all of our topics. And in addition to that, what I'll be doing is I'll be providing you with each big idea from the class. Like one big idea, for example, is quadratics. Right? That was a huge topic that we studied. We studied that for over a month, right? We spent a lot of time thinking about quadratics. In a typical year, in a normal year where we're not in a pandemic, I would have said that trigonometry is a big picture idea. But because we didn't really study trigonometry very deeply, we kind of just grazed the surface. We barely touched trigonometry. Because of that, I will not be putting trigonometry as one of the big picture ideas. I'm just telling you this so you have some idea of what this document is. It's an outline of what we did this year as a grade 11 pre-calculus class. Our section, what we did, me as a teacher, you as a student. These are the topics that we covered. So in each of these topics, I'll kind of give a little brief outline of what the topic is, kind of the gist of the idea, and then I'll provide several examples, like several questions. And if you want, it's not mandatory, this is not part of your grade, but part of the purpose of this document is to give you the opportunity to assess yourself, right? To see for yourself, am I able to do what we did this year, right? Also, I will be giving this to the grade 12 pre-calculus teacher next year. And they will look at this document and say, okay, well, this is what Mr. Bennett did. These are the main topics. This is what I can expect my students to do. And it's up to that teacher to, try to determine somehow to, assess whether or not you actually can do these things, right? Because let's be honest, not all of us are not all of us are taking part in the live streams, and not all of us are submitting assignments and stuff. So so next year you can expect to have some kind of self-assessment or some kind of assessment tool that your teacher will use to determine what skills you actually did have based on the big picture idea document that I will give them. So that's kind of what you can expect over the next couple of weeks. I'm going to aim to have these documents finished by the end of next week. I have several of these documents to create. So yeah, that's kind of what the next couple of weeks will look like. And I'm just seeing right now on Discord, I'm not streaming properly, so I'm gonna go off Discord for just 1 sec. Hold tight, guys, while I figure this out. I think you can probably still hear me though. Let me see if I can do this, and that's still not working, eh? Okay. Hold tight. Close this down, and oh, I think I know why. Window project. What the heck? No, that's not what I wanted to do. I think I'm fine on YouTube. YouTube looks okay. I don't know what's going on here. Screen projector, do that. Sorry, guys. Let's see if that worked. It looks okay here. Looks okay there. There we go. Okay. Now I'm cut off. Right? You guys, is that right? Can you just say yes or no? Am I cut off? Yeah, shoot. Like it's cutting me off at my nose, I think. Oh man. Here I am thinking that, being at home would help. Oh, I think I know why. Okay. It's because I'm zoomed in here in OBS. Scale to window. That's what I want to do. And then I'll do this. Full screen projector. No, that's not what I want to do. Full screen preview. There we go. Back into Discord. This should do it. Please. Oh, and then now there's the bars. What is going on here? Okay. Okay, I'm going to try this. Sorry about this, guys. This is, I'm sure, very annoying for you. So, let's see here. Okay, one more time. Screen. Boom. Boom. Yeah, I mean, there's bars around it. I have no idea what is going on here. But I think, let me try one more try. Change windows. Yeah, just in the interest of getting a move on, can we just deal with this? I mean, you can see everything. There's just kind of gray bars around everything. Yeah, it's fine. Yeah, I know it's not ideal. If you want, you could head over to YouTube and just have that if you want more fidelity, and then continue to use Discord just to chat. Anyway, we're gonna get a move on. So you might be wondering which days of the week we will be meeting. So as of so I guess what I'll do is I'll just write a quick little schedule. Okay, so we will meet, I shouldn't say meet, we will live stream every even day of the school day cycle. The school day cycle. Okay, so today is today's an even day. Yeah, today is, I think, day 6, if I recall correctly. Pretty sure today is day 6. Let me just double check, but I'm almost certain that today is day 6. I think I've got this in my calendar. If you want, if you can go to my website, and I have a link in my website. Today, what's today? The 30th? What's today? 29th. Okay, 29th, day 6. Yes, today's day 6. I knew that it was an even day. I wasn't sure if it was day 6 or not. Anyway, what I'm trying to say is that we will meet every even day of the school day cycle. If you're not sure what the even days are, you can go to my website, and on my website, if you look back at the update that I made a couple months ago, like if you go to the update section, I have a link for like a calendar file that you can, if you want, you can use that file and upload it onto your digital calendar, and it'll tell you what school day it is in your calendar. Or you can just go to the Winnipeg School Division website, or you can just remember the following few dates. So I guess Monday is June 1st. I will be at school, and I will not be live streaming on June 1st. So we will be meeting on June 2nd and 4th. So that's a Tuesday and a Thursday. And then the next week after that will be Monday, Wednesday, Friday. So that is the 8th, 10th, and 12th. 8th, 10th, and 12th. And then the very last week of school, we will meet on the 16th and 18th. 16th and 18th. And you know what? I will probably do something on the 19th as well. Just kind of like a celebration, sort of a high five. Yahoo! It'll be. I'll try to think of something fun for us to do. Maybe who knows? Maybe we can like meet in Minecraft or Roblox or something, and have like a some kind of fun thing that we could do. If you have any suggestions for me, maybe you can. Maybe that's what my exit slip today can be. Is do you have any suggestions for us to do on the last day? Because I think it'll be quite the accomplishment. I mean, I think it is quite the accomplishment that we're even already here, that we've been doing all of this distance learning, remote learning, whatever you want to call it, because it has been a challenge for everybody, myself included. This is definitely the hardest few months of teaching that I've ever experienced, and I've taught in a lot of different situations, and this has absolutely been the hardest. And I can imagine for you as a student of 11 years, this is your 11th year, maybe your 12th year if you went to kindergarten, or 13th year if you went to nursery as well. This has probably been the hardest for you as well. That's what I would imagine. Maybe you've had harder years. I can't speak to that, but I think in general, if I had to guess, this would be the hardest semester that you've faced. By the way, if you can hear Kima in the background, she's crying, she's meowing. I accidentally let her outside of her apartment, and she ran around in the hallway, and whenever that happens, then she always meows for about 2 days to remind us that she wants to go back out into the hallway. So she's just protesting. So don't mind the meows. She's just wanting to go outside. Can you guys hear that? Yeah, kind of a little bit annoying, but we're just gonna have to live with it. Okay. So, if you have any questions about that, don't hesitate to ask. Yeah, yeah, she is very cute. I would absolutely die for my cats. Yeah, without thinking twice. Yeah, absolutely, they mean the world to me. Okay, so let's get started then. So the past couple of classes, what we've been aiming to do is try to get a bit of an understanding for systems of equations. So I'm just going to write kind of a quick breakdown. So systems of equations. Okay, and I'm going to give us just kind of a quick little cheat sheet of what we can do. So, so given two equations, i.e. a system, if we want to find a solution, to the system, we can use Desmos or any other graphing software. To solve the system by finding intersections of the graphs. Okay, so that's kind of what I've been trying to show you over the past couple of days, is that if I give you several equations and I want to know a solution or several solutions, or maybe just the fact that there are no solutions, then one way that you can do this is to use Desmos or any other kind of graphing software. I try not to overwhelm my students with too many different ways of doing something. So if you have a different piece of software that you prefer to use over Desmos, by all means, use it. If you own one of these and you want to learn how to graph systems of equations using this, you absolutely can. I will not show you how to do that in class though, because I don't expect everyone has this calculator. It's a very expensive calculator and you don't need it for this class. But maybe you have it because you need it for a different class, or maybe you think that you might need it in the future, so you went out and bought one. Or maybe you just thought it was super fancy and fun and you just got it anyways because you are super into math and you like this kind of thing. That's great too. But I'm not going to show you how to do it using this calculator. You can look it up on the internet. It's not super hard. But the way that I prefer is to use Desmos. Desmos seems to just be very readily available. It's just on the internet. It's a few clicks away. We're all able to do that. And right now, I don't have to worry about cheating on a test or anything like that. So I can fully just say, yeah, Desmos totally works. Feel free to use Desmos for all these questions. Now keep in mind, what I'm going to show you now is I'm going to show you how to solve systems of equations without using any kind of software. So no computers. So that's kind of our goal for today, is to look at how to solve systems of equations with no calculator. Okay? But I still want you to know that you can solve them with Desmos. And if I think that there will be one more very small assignment. Oh yeah, that reminds me, I have to talk about your assignment. There will be one more small assignment, like a very small assignment, before the project. So between now and when the project is due, there will be right around in the middle of that. So sometime, not next week, but the week after that, we will have one more small assignment where I just ask a couple of questions about systems, and then that's it. Yeah, so you can use Desmos for that assignment. And it reminds me, I have to talk about your assignment because somebody reminded me that I neglected to put a due date on the assignment. So I intended on having the assignment due today, and I think I mentioned that several times in the live stream. But because not everybody is watching the live stream, and I know that that's not necessarily fair to everybody, but ultimately this is my fault. So I really should have put the due date on Google Classroom. I'm not sure how I missed that. I had 3 other assignments for my other classes, all with assignments due this Friday or today, and for some reason this was the one that I forgot to put the due date on. So anyways, I just in case you're working on it now and you're like, wait, what? It's due today. I extended the due date till Monday, So you still have the weekend to complete it. So it's due on Monday at the end of the day. So if you've already sort of scrambled to get it done, I'm sorry that that is unfair, because you got it done for Friday and other people didn't. All I can say is that I'm sorry. It's my fault, and I hope that you don't think negatively of other students, because they just didn't know. So yeah, be mad at me. Don't be mad at other students. Okay, so we've got systems of equations. That's what we're going to look at today. What I'm going to do is I'm going to just take a look at one of the systems that we looked at first. In fact, the very first system that we looked at from a couple of, I guess it would have been over a week ago now. This one right over here. Okay, so the reason I want to do this one is because we estimated this one already. We took a look at this one and we guessed approximately what it was. And certainly we could go to Desmos and we could graph both of these lines, and we could use a graphing calculator to say, okay, what is that point of intersection? Like you could graph this line, you could graph this line, and then you could just click right there, and then it would tell you the exact coordinates, and then that would be the solution to the system. I want to show you how to do this without any calculator. Oops, so I'm going to do this. I'm just going to copy this system. Copy. Scroll down. Paste. Okay, so this is the system. So if I gave you these two equations and I asked you to solve them, this is the process that I would like you to do. So this method is called substitution. Okay, so we're going to start off with a method called substitution. Okay, so the steps for substitution are the following. Step 1 is isolate one variable. In one of the equations. Okay. Now, step 2 is to replace, or I should say, in the other equation, replace that variable with what you solved for in step 1. Okay, and I'll illustrate this. So if the English doesn't make sense, like if this sort of outline, this description, this procedure doesn't quite make sense, hopefully when we actually do a couple examples, you'll see what I'm talking about. So in the other equation, we're going to replace that variable with what you solved for in step 1, and then step 3 is to solve for the other variable. Okay, and this method is called substitution. So that's what we're doing here. So let's go through this. So I'm going to call, just to make things a little bit easier, I'm going to call the yellow equation equation 1 and the pink equation equation 2. Okay, it'll just make it easier to refer to these equations. So step 1, to isolate one variable in one of the equations. I'm going to focus my attention on equation 1. Now, lucky for us, the way the question was given to us, or the way we got okay, I don't see timestamps on here, so I'm hoping that I answered your question regarding the assignment due date. Yeah. Okay. So lucky for us, the form that the equation came in, we already have isolated one of the variables. So step 1 has been done for us. What I mean by that is that y is already by itself. Y is isolated. It's all by itself. Y has been isolated. So in this case, y has been isolated. So step 1, let me get my marker back. Step 1 is finished. So let's talk about step 2. So step 2 says, in the other equation, replace that variable with what you solved for in step 1. Well, we didn't really solve for anything, but what I mean by that is I'm going to say, okay, well, if this is what that y is, well, these two y's are going to be the same. Okay, so if y is equal to 2x plus 1, and y is equal to this big mess, well then, what I'm going to do is I'm going to take this, I'm going to replace it with that. So in other words, I will have 2x plus 1 is equal to negative 1/2 x minus 2. Okay? Now, that's just an equation. It's an equation with one variable. So we can solve it. And that's what we're going to do. So what I'm going to do is, let me just zoom in here so I can actually do some algebra. So I'm going to just solve this equation. So I'm going to bring all the x's to one side and everything else to the other side. So I will add both sides with 1/2 of x. I'm going to subtract both sides by 1. So I'll get 2x plus 1/2 x equals negative 2 minus 1. Effectively, what I did is I moved this over here. That's why I have this. And I took this and I moved it over here, and that's where this comes from. So 2 plus 1/2, well, that would be 4 halves plus 1/2, which is 5 halves. So I've got 5 over 2x equals negative 3. Great. Now I'm going to multiply both sides by 2 over 5. So I'll do times 2 over 5 times 2 over 5, and I get that x is equal to negative 6 over 5. Okay? And that is equal to 1.2, or negative 1.2. Awesome. So that's what x is equal to. Let's figure out what y is equal to now. Okay? So if x is equal to negative 1.2, I'll just say x is equal to negative 6 over 5. Then let's figure out what y is equal to. So I'll write if x is equal to negative 6 over 5, let's figure out what y is equal to. So what I'll do now is I'll go back to either one of these equations, and this is the beauty of it, is it doesn't matter which equation you choose. Okay, you could choose equation 1 or you could choose equation 2. I'm going to choose equation 1. The reason for that is because it doesn't have any fractions in it. I don't want to have to deal with that fraction. So I'm going to avoid fractions at all cost. Fractions are where most people make mistakes. So if you can avoid using fractions, then by all means avoid using fractions. Now keep in mind, here's a fraction that we're going to have to use anyways. So we are going to use fractions anyways, but we'll have fewer fractions to deal with. So the equation was y equals 2x plus 1. So we've got y is equal to 2 times x, which is negative 6 over 5 plus 1, right? And I'm just going to say that that's what x is equal to, right? Because we solved for x. We solved for x. We learned that x is equal to negative 6 over 5. So y is equal to 2 times negative 6 over 5 plus 1. Now let's go ahead and solve this. So I have that y is equal to, well, that will be negative 12 over 5 plus 1. And, this is going to be plus 5 over 5. So that will be, what is that, negative 7 over 5. So y is equal to negative 7 over 5, which is equal to negative 1.4. Okay. So my solution is, well, x is equal to negative 6 over 5, and y is equal to negative 7 over 5. Or, if you want, you could use decimals. You could say x is equal to negative 1.2, y is equal to negative 1.4. Or what you could do is you could give it in terms of a point on the plane, like the xy coordinates of that intersection, right? Like where do they intersect? Well, they would intersect at negative 1.2, negative 1.4. Okay, and now what I'd like to do is I'd like to kind of go back to our graph from the other day and see what we guessed. We guessed it was like around negative 1.25, negative 1.25, right? So that was actually quite a good guess. And we just guessed that from observation. But using algebra, we were able to determine the exact value. Okay. So the trick, and we did this and we did this. So the trick here is to isolate one variable, substitute whatever you figured out that variable is equal to into the other equation, solve for that variable, and then now you've got one variable, so now you can find the other. So it's kind of like juggling with the variables. You kind of solve for one, get it by itself, throw that into the other equation, and then take it from there. So let's do another example. This one I'd like to do with a quadratic. Okay, so let's do a quadratic one. So I've got this one's from your book as well. So if you'd like to follow along, you can do so in your book. But I don't think the book solves this one for us. Actually, no, let's do this one. Okay, so I've got 5, I'll say solve this system. Okay, so I've got 5x minus y equals 10, and x squared minus x minus 2y is equal to 0. Whew. What a nasty looking equation, or system of equations. Like, if you've never seen this stuff before and you have no idea what to do, this could look a little overwhelming, right? Like, really what we're looking for, like, this is what we want. This is what we want. We want a value or values of x and y that satisfy both equations. That's what we're looking for. We're looking for a value of x and y that I could put into this equation to make it true, and I could plug it into this equation and make it true, right? So that's what we're looking for. That's our goal. And on first glance, it might look a little daunting. You might say, well, I don't know where to begin. Well, let's just follow our steps. So step one, solve for one variable. Okay. Now, I don't know about you, but I don't really want to solve for one of these variables over here. I mean, I guess I could solve for y, and that wouldn't be the worst thing in the world. But yeah, I'm thinking that it'll be better if we stick to this one. Let's just leave the quadratic stuff for later, because it's going to be a little bit tricky. What we'll do is we'll solve for one of these equations, one of these variables. So I'm thinking that we could solve for y here, and keep in mind it doesn't matter which variable you choose. And it doesn't matter which equation you choose either. I'm just thinking that this one is going to be a bit of a mess, right? It's going to be a little bit gnarly to try to figure out like what one of these variables is all by itself, right? So what I'm going to do is I'm going to stick to just to the linear equation and see what I can get out of that. And then whatever I do get, I'm going to plug into this equation and take it from there, okay? So my choice is equation 1. So here's equation 1, here's equation 2. I'm going to solve for y. I'm going to solve for y in equation 1. So I've got 5x minus y equals 10. 5x minus y equals 10. And what I'm going to do is I'm going to bring the negative y over here and the positive 10 over here. So I'll get 5x minus 10 is equal to y. So I solved for y. Y, I've just determined, is 5x minus 10. And now I can work on step 2. So step 2 is to substitute. Okay, so I'm going to substitute this value of y that I got into the other equation. So I'm going to go and this is kind of the notation that my old university professor taught me. And I really like this notation. So what he would do is he would say, okay, well, I'm taking what I learned from equation 1, and I'm going to substitute it into equation 2. Right? So I'm taking equation 1, and I'm putting it into equation 2. And that's what I'm doing. Okay? So I'm going to take this y, and I'm going to put it, here, I'll do this. I'm going to take this y, and I'm going to put it into this y, right? Because I know I've got all this stuff, minus 2 times y, and here I just solved for y, so I know what y is actually supposed to be equal to. So let's go ahead and do that. So what am I doing here? I'm just going to leave that up. So I'll say that I've got x squared minus x minus 2 times y, and y is this thing, which is 5x minus 10. And all of that, don't forget, this is the original equation that we're working with. All of that is equal to 0. It's equal to 0 because I've got equals 0 over here. So really all I did was I took this equation and I rewrote it. Here it is here, except instead of writing y, I solved for what y is equal to according to the other equation. The whole point of this is that we're trying to combine these equations into one. So we've got two equations. I'm trying to smash them together into one using algebra. And the whole idea here is that if there's a solution, right? If there's a value of x and y, right? If there's a value of x and y that work, then it's going to be the same x and the same y in both equations, right? I want that. So what I'm doing is I'm assuming that the y's in these equations are equal. I'm saying, well, this y must be the same as this y, and this x must be the same as this x and this x. That these variables are the same numbers, right? Keep in mind, I am not saying that x is equal to y. X and y could very well be different. In fact, they're almost certainly going to be different. They could be the same, if that would be a coincidence. What I'm saying is that the y's are the same and the x's are the same, okay? So if they're the same, then I can replace one with the other, right? Like one y is equal to another y. So if y is equal to this, well then why am I writing y when I could write this? And then when I do that, now I've eliminated one of the variables, right? One of the variables is now gone. I've gotten rid of y. Y is now out of the picture, and now I have a quadratic equation with just one variable, and we know how to solve that. We can solve this using the quadratic equation. Or maybe we could, who knows, maybe this will be really nice and maybe we can just factor it. Anyways, I'm blabbering, so let's get on with it. So I'm going to go ahead and simplify this. So I've got x squared minus x, and then I'm going to use the distributive property to distribute this throughout. And I'm going to get minus 10x plus 20, and this is all equal to 0. Good. Now what I'm going to do is I'm going to combine these like terms. So I'm going to get, x squared minus 11x plus 20, and that's equal to 0. And now I'm looking for two numbers whose product is 20 and whose sum is negative 11. So I'm just thinking about that. It couldn't be 4 and 5. Yeah, I'm thinking that. Oh, did I do this wrong? I don't think so. What did your book do here? Okay, so they did the same thing as us. They said it's 5x minus 10. Oh, I think I wrote the question down wrong. Yeah, I wrote the question down wrong, folks. Lucky for us, it's one of those mistakes that's very easy to fix. This minus sign is supposed to be plus. Yeah. Otherwise, the equation would be kind of a little bit annoying to solve. This is supposed to be a plus. So if you're following along and you're writing, go back and just turn that minus sign into a plus. Super easy typo to fix. These should all be pluses, which makes this negative 9x. That's much better. I'm so much happier now. So this looks much easier to factor. I'm going to have x minus 4 and x minus 5 equals 0. Okay, that looks good. So those are my, so look at this. Now I've got that x could be equal to 4 or x could be equal to 5. Look at that. So I have two solutions here. Now remember, if you've been following along very closely, let me just scroll back up to a couple days ago, I think yesterday actually. There are three situations, three possibilities. We could have two solutions, right? Here's a quadratic, here's a linear equation. They have two intersections. That's the first possibility. The second possibility is where the linear equation is tangent to the quadratic, and their intersection is the point of tangency. That's the other option. The last option is that there are no intersections. In other words, no solutions. So, you can probably start to see how that could be possible, how you could have no solutions, right? Because effectively what you're going to be left with is you're going to have some kind of quadratic equation to solve. And we've seen that quadratic equations can have several different types of solutions. They could have one solution, two solutions, or zero solutions. We got two solutions this time, which means now we have two different values to sub back into the other equation. So if x is equal to 4, so if x is equal to 4, then y is equal to, well, let's go back to our original equation, or one of the original equations, equation 1, 5x minus y equals 10. Well, let's actually use this because we've already solved for y, so that it kind of does all the work for us. So in other words, y is going to be 5x minus 10. So y will be 5 times x minus 10, and x we said is 4, so I'm going to get that y is equal to 20 minus 10, or in other words, y is equal to 10. The other option is if x is equal to 5, right? Because we had two different values for x to solve for. So if x is equal to 5, then y is equal to 5 times x minus 10. Well, x we said is 5. So we'll have that y is equal to 25 minus 10. So y is equal to 15. So our two solutions are 4, 10 and 5, 15. Okay? And that's our two solutions. So we have two solutions to this system of equations. And it's important to know that you can have two solutions, just like you can have two solutions to any kind of quadratic equation. Because at the end of the day, all we're doing is we're just solving for this quadratic equation. So I would like to graph this, but I'm already over time. So we're going to leave it as is. Next class, I'll start off by kind of revisiting this equation, and we'll graph it to kind of verify that this all kind of makes sense. Okay. So for the exit slip today, as I said before, exit slip. If you have any ideas for our last class, which is on June 19th, let me know. So last class, fun activities, any ideas? So I mean, if we wanted to, we could like maybe we could get together in Minecraft and have kind of like a celebration or some other kind of video game. I like the idea of Minecraft though, because as far as I understand, I'm pretty sure that everyone at the Winnipeg School Division has a free Minecraft account. So I think that it could be accessible in that way, so that could be kind of fun. But maybe not everyone's into Minecraft. Maybe you just kind of want to hang out here and just kind of chat. Or maybe I could try to get something involved with Goose and Kima. Maybe they could plan something. So let me know if you have any ideas that you'd like to do for the last class, because it is coming up. So after today, we have 3 weeks of school. Isn't that crazy? 3 weeks. So yeah, things are starting to come to an end. So yeah, and if you have any issues with the assignment, please let me know. I'd love to help you out. I guess it's not due at midnight like I originally planned. So it'll be due on Monday at midnight. So everyone gets a free extension. So if you want, you can, if you need to, you can resubmit. If you've already submitted, you can kind of go over your answers one more time and make sure everything looks good. But yeah, again, I'm sorry that I made that mix up. So have a good weekend, guys. I miss you terribly. I wish that I could just see all your darn faces, because yeah, I really miss you. And that's from the bottom of my heart. I really wish that we could just be together and have a normal class, and that things could go back to normal, but they can't. There's no normal anymore. Normal does not exist. So yeah, take care, and I'll talk to you guys on Tuesday. Our next class is on Tuesday. We're now going down to every second day. So that's our new schedule. So every second day. Just a quick reminder. I'll just throw that up. Oops, not that. This. So June 2nd, 4th, 8th, 12th, 16th, 18th, and 19th. So those are the days that we're going to be meeting. So, okay, bye-bye, guys. Bye-bye. Okay, and let me close down YouTube. Okay, bye-bye, YouTube.